Hey guys, so section 2 in chapter 2 is on scientific notation. And basically scientific notation is just a simplified way to write really large numbers or really small numbers. It's like an abbreviation, like don't, the abbreviation is replacing the O and do not. Scientific notation is kind of like that. It's an abbreviation of numbers. So scientific notation, there are 3 parts to the number. So if you look right here, here's the number that's written in scientific notation, 3.5 times 10 to the 5th meters. There are 3 parts. The coefficient, which is going to be the number here before the times sign. Okay, so green, coefficient for green, here's how it matches. A power of 10, so that's going to be right here, which is basically going to be the 10 to the 5th is 5 units of 10. Okay, and then your unit of measurement, which in this case is meters. So here's how this works. Let's say we have something that measures 25,000 meters, and we want to write that in scientific notation. So what we're going to do is we're going to move the decimal until it is between the first 2 non-zero numbers. And as you move it to that place, you're going to count how many places you move. Okay, and this will become your power of 10. So I have 25,000, so I'm going to move my decimal, this is where my decimal would start, to the first 2 non-zero numbers. So we're going in this direction, 1, 2, 3, 4. Our decimal would be right here, so that's going to be our 2.5, all right? And then 10 to the 4 is going to be the fact that we move the decimal 4 spots. All right? So 2.4 times 10, 2.5 times 10 to the 4th meters. We moved it 4 places. So hopefully that makes sense. Now, sometimes your power of 10 can be negative. Sometimes it's positive, sometimes it's negative. So determine whether or not your powers of 10 is positive or negative or not. What you will do is that you will, if you move your decimal to the left, okay, the power of 10s will be positive. So if we are moving here to write this in scientific notation, we move it to the left, 1, 2, 3, 4, 5, okay, so we know that our power of 10 is going to be 5. Because we moved it to the left, we know that this 5 is positive, all right? And the 2 numbers would be 6.7. So 6.75 times 10 to the 5th centimeters. I need to get an Apple pen so I don't look like a 3-year-old writing, right? If you move your decimal place to the right, the 10's power will be negative. So in this case, we're going 1, 2, 3, 4, okay? So we have 6.89 times 10 to the negative 4th power centimeters. Okay, so because we moved that direction right, we moved the decimal place right, then the 10's power is going to become negative. So just remember that you're always going to have your decimal point between the 2 non-zero numbers. You're always going to have a power of 10, and the power of that 10 will be the number of decimal points you moved in order to move that decimal to in between the first 2 non-zero numbers. If you're moving to the left, this number will be positive. If you're moving to the right, then this number would be negative. Now, you can work backwards in this process too. If you're given scientific notation, then you should be able to move it to a standard number. So again, if the power of 10s is positive, you're going to move the decimal place that many numbers to the right. So we have 4.32 here. Right? So we're going to move the decimal place to the right 2 spots. 1, 2, okay. Fill in where the 0 would be, so your answer would be 430 liters. All right. If the power of 10s is negative, then you're moving the decimal point to the left. So 1, 2, because it's -2. Fill in the 0 for that placeholder there, and you would have 0.043 liters. So we're going from scientific notation to a standard number. Look at the power. The powers here will tell you how many spots to move. The negative or positive will tell you what direction. Practice some of these problems, and if you are still struggling with this, then please do not hesitate to hit me up and I will help you. So have a great rest of your day.